Hello, everyone, and thanks for watching. This is part two of the theory of ground reference maneuvers. If you have not watched part one, I highly recommend you do that first so that you have the background information on what it is we're discussing in this video. For those of you who have watched part one, just as a reminder, this is where we talk about the theory of a few actual ground reference maneuvers, which you'll be required to do in the Red Cell Private Pilot Program. So, what we want to talk about first here is, again, we're going to go back to the objective. This is objective number 3 for this lesson. Learn how to correct for wind drift and changing ground speed to maintain a specific ground track by performing ground reference maneuvers. So in our last discussion, in the last video, we learned what all those key terms mean. We talked about this illustration here on the bottom of the screen. How do we get from A to B in a straight line even though there's a wind? We understand those things. We understand how to apply wind correction angle and negate wind drift. We understand how our ground speed and our ground track function with one another. We understand those concepts. So what we're going to do here today is we're going to talk about a few of these ground reference maneuvers and the theory behind them and what we're looking for when we're practicing them, how we can accomplish them successfully. So disclaimer here. This is not meant to be your instruction. You're still going to need to practice these maneuvers with your instructor. You're still going to need to ask questions. You're still going to need to brief them. And I'm going to omit a lot of information that you're going to need to practice these maneuvers. This is literally just the theory behind the ground reference maneuvers, all it is. So there's some information, some further information that you'll need before you actually can go out and accomplish these maneuvers successfully. So let's get started with, in my opinion, what the easiest ground reference maneuver is, and that's the rectangular course. So what we're trying to do here in the rectangular course, if you look at the rectangle that's drawn there in blue, you see that the airplane is essentially just flying outside of the perimeter of that rectangle. And what we're trying to do is we're trying to make the airplane's ground track run parallel and congruent with that rectangular course there. That's what we're trying to do in this maneuver. So you'll see that I've got the rectangle divided into 4 quadrants. So what we're going to do is we're going to start with quadrant number 1, and we're going to talk about what's happened in this maneuver. So if you'll recall to your notes from the last video, we understand that the airplane is going to be doing 2 things in this maneuver. It's going to be applying wind correction angle, and it's going to be adjusting its rate of turn based upon its ground speed. We know those are the 2 things that are going to happen in order to make this, in order to negotiate this maneuver. So let's talk about what's happening in number 1 there. So if you see the top of the screen, the airplane as it flies horizontally across the screen there in quadrant number 1 is going to have to apply a little bit of wind correction angle into the wind. So it's going to have to turn a little bit towards the bottom of the screen. As it makes its turn into the wind, as it starts traveling upwind, we know that the airplane is now going to be traveling slower across the ground. The ground speed is going to be reduced just by making that turn into the wind, turning upwind. So there's 2 things that we know in quadrant number 1. We're going to have to apply some wind correction angle into the wind, and as we make the turn, our ground speed is going to slow. Now, we can relate these things because we learned this last video. As ground speed decreases, the rate of turn can also decrease. Okay, so here's what we know. The upwind segment on the left side of the screen is going to be much longer time-wise to travel the same distance as the downwind segment on the right side of the screen. Why? Because your speed changed. Your ground speed changed, therefore it's going to take you a longer amount of time to travel the same amount of distance. Okay, so you don't need to turn as steeply because you're going slower, right? And remember, we're not talking about bank angle. Bank angle, however it may increase, that's not what we're talking about here. We're talking about rate of turn. All right, so now we're down to quadrant number 2. So number 2, you're going to be going from your slowest ground speed to a slower ground speed, not the slowest that you're going to travel, but a slow ground speed. So you're going from the slowest ground speed to the slower ground speed. So that's going to require that you do two things. One, you're not going to need near as much rate of turn because you're going slower. And then two, you're going to have to apply some wind correction angle into the wind. Okay, so that's going to be your shallowest turn, number two. And number three, we know we're turning downwind, so we're going to be gaining ground speed as we make that. So we're going to have to turn a little bit steeper as to not cover as much ground. Now remember, this segment of this maneuver is going to be much quicker than the other segment, than the upwind segment. And then number four is going to be your steepest turn. Why? Because you're going from your fastest ground speed to a fast ground speed. So your fastest two quadrants, and when I say fastest, I'm pertaining to ground speed and time traveled, is going to be quadrants 3 and 4. Your slower quadrants are going to be 1 and 2. Why? Correct. You have a slower ground speed on 1 and 2 than you do 3 and 4. Okay, so those are the things we need to understand in order to break down these maneuvers. So as you're conducting this rectangular course maneuver, what is important to know? Where's the wind coming from? Am I on the upwind segment or the downwind segment? Which direction is the wind coming from in relationship to my flight path? Do I need to be applying wind correction angles so I'm not being affected by wind drift? Very important things to ask. Okay, so that's the rectangular course. Let's move on to in my opinion, the next simplest one, which is a turn around a point. And all we're trying to do in a turn around a point you see here is just it's a constant radius circle that we're going to try to fly with our airplane around a point. It's essentially the same concept as a rectangular course. It's just we're not squaring the corners off, we're rounding the corners off. We're trying to keep a constant radius. So the airplane should never be stopped in a turn. It should be turning all the time, and we just adjust our rate of turn to keep a constant radius. So if we're looking at quadrant number one here, we'll start the same way. We know in quadrant number one, our ground speed is going to be decreasing. Why? Because we're turning upwind, we're turning into the wind. Same thing with quadrant number two is the rectangular course. We know this quadrants 1 and 2 are going to be the slowest in terms of ground speed and time over the ground as opposed to quadrants 3 and 4. So it's not going to require near as much rate of turn on quadrants 1 and 2, and it's going to take a lot longer as opposed to 3 and 4, which you'll need more rate of turn, and it's not going to take you near as long. So in other words, it may take you 1 minute to do the upwind side. It may take you 30 seconds to do the downwind side. It just depends on what the velocity of the wind is. Very important to know. So same thing we're looking for here. Where am I in relationship to the wind? Okay, what's my ground speed right now? Do I need to be applying more wind correction angle or less wind correction angle? Very important to understand in a turn around a point. Okay, and then probably the most complex of all the ground reference maneuvers that you're going to practice on lesson 6 are the S-turns. Okay, we need a little bit of background information on S-turns. So S-turns are not the same as rectangular courses and turns around a point. You're not trying to keep a constant distance from anything. You're trying to make sure that when you roll out over this road here, see the line that's thicker than the other lines? That's your ground reference point. You're trying to make sure that when you roll out over the top of that road, your ground track your ground track for sure is perpendicular to the road. Your ground track and your heading, essentially. And the way we're going to control that is we're going to make sure we pick the appropriate road in relationship to the wind, which your instructor will cover with you how you can do that and how you select the area in which you're going to maneuver. But that's not really what we're talking about today. So our objective is not to keep a constant radius. Now, I know the track that you see here, the line I have drawn that the airplane is flying, looks like it's a good, nice constant radius, but in practice, that's not the way that it's going to look probably. It's not going to be a nice S. That's not really what we're trying to accomplish here. What we're trying to accomplish here is we're trying to make sure that our nose, our ground track, our heading are all perpendicular to our reference point, road, power line, island, whatever you're using for your reference point, that your airplane's nose, heading, ground track are all perpendicular to that once you cross over the road. So as you cross over the road, we're going to start here on the left side of the screen with quadrant number 1, just like we've been doing. We know two things, right? We know that our ground speed is going to be increased. Why? You're going downwind. And we know we're going to have to apply a lot more wind correction angle to correct for that wind drift as we start turning back into the wind. Now, at quadrant number 2 here, this is where the S-turn gets a little bit more complicated. Think about this now. Now, you're turned back into the wind. So you went all the way from downwind straight back into upwind. So what has to happen as you make this turn here? So you're going from really fast to going back into the wind. So as you start to make that turn from quadrants 1 to 2, what does your rate of turn need to do? It needs to decrease. It needs to become more shallow. It needs to become more shallow as you go from quadrants 1 to quadrants 2. And that's on the downwind side of the road. On the upwind side of the road here, we know that if we're at quadrant number 3, we're going to be going from slow to fast. So what does that mean? That means we're going to have to apply a different amount of wind correction angle, and our rate of turn is going to be increasing. Why? Because you're going from you're going from slow to fast. So your rate of turn is going to have to be increasing. At quadrant number 4, you go from a headwind to a tailwind. So you're going to need to really increase your turn as you go from there. So on what we'll call the upwind side of the road, what happens? Your turn rate goes from shallow to steep, as opposed to the downwind side of the road at the top of the screen, which goes from steep to shallow. So what the whole takeaway from this whole video, right? All three of these maneuvers we just talked about. What's the common denominator? What's the common denominator for all these quadrants that we talked about? Same thing we talked about in the first video. Depending on where your flight path is in relationship to the wind, that's going to determine how much wind correction angle you need to apply. And 2, as your ground speed increases, your rate of turn is going to have to increase. So when you're practicing these maneuvers, you got to know where the wind's coming from. You got to know where the wind's coming from, and you got to know where you are in relationship to the wind so that you can apply these principles. What does my wind correction angle need to be to stay either a rectangle or a constant radius, or make sure that I'm rolling out perpendicular to the road? What does my wind correction angle need to be? And then what is my ground speed? What is my ground speed? Am I going downwind right now? Is my ground speed quicker? Am I covering a greater amount of ground in a shorter period of time because my ground speed's increased? Or am I going upwind and it's going to take me longer to get where I need to be than it did a minute ago? All important concepts to understand if you're going to be great at these maneuvers. So I hope this is helpful. If you're struggling with ground reference maneuvers, if this is something that you don't quite understand, you're always welcome to reach out to us here at Red Sail Aviation. You can send us an email. You can comment on this video. You can reach out to us via phone. We'll be happy to explain anything we can to you. Yeah, so this has been good stuff. This is a maneuver that if you get really good at this, you'll see a lot of other areas in your piloting abilities will increase. So really thank you for watching. And again, never hesitate to reach out to us here at Red Sail Aviation, and we'll be happy to help you in any way we can.